In this section we're looking at second derivatives, and we also look at second derivatives in the next section as well with respect to points of inflection. But for now we're just looking at how to find the second derivative. Now it's really just another step on top of what we already know how to do. So far we've been able to find first derivatives, and we know that first derivatives we use the notation f-x, that's a first derivative. For the second derivative, we use the same type of notation, but this time we use two dashes, so f double dash x for the second derivative, or we also have used dy dx for our first derivative. When we look at the second derivative, what we're doing for our second derivative is we're actually taking the derivative with respect to x of dy dx, because that's our first derivative in here. This is the second time we're differentiating. And what happens when you actually take that d dx? The d, you can see there's two d's there. So there's what we write it as a d squared y, the two d's together. Effectively they're timesing together. And on the bottom you've got two dx's. So we write the bottom line as dx squared. Okay, so you can see that notation there as well. So either one is fine for your second derivative, either the d squared y dx squared or the double dash notation. Okay, so for the questions we're doing here, you can see with the first one, we've got the function given to us, f of x. It says find the second derivative of the following with respect to x. So that means differentiating with respect to x, d dx. So for A, what we've got, our first derivative, remember that the powers go out the front, multiply out the front. There's a power of 1 here that would multiply out the front. So with the first one, we'd have 6 times 4, 24x, and we take 1 off the power, so cubed. The 3 comes and multiplies with the 4, minus 12x squared, and the 1 multiplies with the 4, and the power of x goes down by 1, so x to the power of 0, which is 1. The second derivative is just doing exactly the same thing again, the 3 coming out the front, multiplying, the 2 multiplying, and this constant then turning into 0. So 24 times 3 is 72. Power of x goes down by 1 to a squared, and we have 24x. Now that's our second derivative. If you wanted to, you could factorise that as well, take the x's out or take common factors out between 72 and 24, but I'm just going to leave it like that. So that's our second derivative. So differentiating twice for second derivative. Okay, the next one we've got there is b. We've got y equals e to the x, sine x. And you can see here that we've got two functions multiplied together. So we'd have to use here product rule. So we're going to use product rule on this not once, but we'll see that we actually have to do it twice. So I'm just going to move this notation down. I might actually use this other form of notation for this question too, because we'll do the derivative of each side. So the first level, we've got dy dx equals the derivative of e to the x sine x. And you can do this with all the steps if you want. I'm actually going to put all the steps here just so you can refresh yourself on your product rule. So derivative of e to the x is e to the x. It's a lovely one. Derivative of sine is cos. And our product rule is u dash v plus v dash u. So we've then got dy dx equals u dash v, so e to the x times v, which is sine x, plus v dash, which is cos x times u, e to the x cos x. With this one, it's actually advantageous for you to factor out the e to the x, because it will make the second level of differentiation a bit easier, because you're going to, you can see, use product rule again, but this time you've got these two products. If you leave it with this form here, you're actually going to have to use product rule twice, so it's better for you to factorise. So now we're going to look at the second derivative, and you can see here underneath what I've kept is our second derivative is that d squared y dx squared. So that's what we're going to be finding. So that equals, I'll do this in green actually, the derivative d dx of e to the x sine x plus cos x. And again, you can do a similar thing. So let u equal e to the x, v equals sine x plus cos x. U dash is e to the x, v dash is cos x, and this time the derivative of cos is actually negative sign, so you introduce a negative there. And our product rule, u dash v plus v dash u. I'm just going to rub out this side here. Oops. So I'll get rid of part A. We've done that one. So that leads us to our answer. So we've got d squared y dx squared, our second derivative, is equal to u dash v, so these two multiplied together, e to the x outside of sine x plus cos x, and then plus e to the x, it's these two together then, u and v dash, e to the x outside of cos x minus sine x. And what you'll notice there is you've got e to the x cos x plus e to the x cos x. Well, that's two lots of e to the x cos x. And if you look at this, you've got a sine x, and here you've got a minus sine x. So you'll actually have some cancelling going on with these two things. So your final answer, all you're left with, you could also expand this out to get to the same result. For your second derivative is two lots of e to the x cos x. So our second derivative, d squared y dx squared, this is for b, is 2e to the x cos x. So depending on how you want to use your notation, it really depends on what you're given in the question. You could also have expressed this answer as y double dash as well. So either one of those is acceptable. I'm just showing you both options so you can pick which one you're happier with. But it makes sense when you're given f of x to use the dash notation. So second derivative, just like first derivative, you're just going one step extra to get to that second stage.